So by getting started, we're going to start with fractions and decimals, and that PDF, when you download it, looks like this. So I'm going to go between this and then a live feed where you can see me writing some examples. So I'm going to walk through this and we will use that as a guide. So the first thing we're going to talk about, I'm going to write some examples here. The first thing we're going to talk about is really this idea that, well, let me back up one step. Every single one of you has had fractions in your life. You've already learned this. I totally get that. This is a review. We go through fractions and talk about decimals in a really pretty different way from standard math sorts of things in the beginning of this class. And the reason for that is because a lot of people don't really remember how to deal with decimals. So that's why we do this in the first week, so we can kind of do it as a warm-up. We can talk about the problem solving part of it, and it kind of helps us dive into this whole math online thing too, with something that everybody's seen before. So if we look real quick at my handout again, that's accessible in the module, you'll see that there's some rules about fractions. So common fractions have a numerator and a denominator. Again, I know this is a review for everybody, but this also means that the top, the numerator, can be divided by the denominator, or the bottom. So you see that it says it means divided by. So x divided by y, or 2 divided by 3. Okay. So that's important because that's also how we change a fraction to a decimal number, which we'll get to in a little bit. Proper fractions are fractions that have a smaller number on the top than on the bottom. So the numerator is smaller than the denominator. Improper fractions are fractions where, like the 3/2 here, where we have a numerator that's larger than the bottom. Like fractions mean that the denominator, or the bottom number, is the same, and mixed numbers are whole numbers with a common fraction behind it, like 2 2/3 that you see here. So I have a lot of notes in here, so if you don't remember exactly everything that I'm talking about, the notes have a lot of detail. So we're going to talk about all of these things. I might pull this back up here in a moment. Come on, you can do it. There we go. There we go. Sorry about that. Okay. So, there's really some things that are super handy about fractions, and believe it or not, fractions are also a good warm-up for algebra, because there's a lot of consistency between how fractions behave and how we have to deal with variables in algebra. So to get us started with that whole idea, let's talk about equality of fractions for a minute. So if I have a fraction, let's say something real simple. So we start off with 1/2. If I multiply the top and the bottom by the same number, it could be any number. Let's say we multiply the top and the bottom by 4. So if I multiply the top and the bottom by the same number, what I'm really doing is multiplying by 1, which is why this works. But what we get out of that is a fraction that appears to be different. So we would have 4/8, because we would multiply the top and the bottom each by 4. So we would have a fraction that looks very different from the 1/2, but inherently is the same thing. This is called equality of fractions. And it is incredibly important for all sorts of reasons that we'll get into. It's very powerful to understand that this can be equal to this. And if you just think about that for a second, that's very special, because if I said that 1 was equal to 4, like if I just took the two top numbers and said 1 was equal to 4, we would say, no, that's crazy. Right? That can't be right. Whoop. So we know that, but in fraction land, we can actually have this behavior where we multiply the top and the bottom, and we actually have something that's equivalent. So 1/2 and 4/8 are exactly the same thing without question. Okay, so that's equality of fractions. Next week when we talk about ratios and proportions, this is going to be a really important thing to understand. All right, so let's also talk about like fractions. So like fractions, or ones that have a common denominator. So this idea of like fractions means they have a common denominator. Who cares, right? Well, what that means is the bottom number is the same. So in things like addition and subtraction require a common denominator. We're going to practice that in just a little bit. But this also mirrors what we will see in algebra with behavior with relation to addition and subtraction. Addition and subtraction are the tricky ones, believe it or not. They're the ones when you have fractions and algebra, they create a little bit more work. There's just a little bit more to do to make sure that you're getting the right outcome. So like fractions means common denominator. Hang on to that. And then we have these different kinds of fractions that I just talked about just a minute ago. So for example, the 2/3 example is a proper fraction. 3/2 is improper. Now, I've always kind of thought that that was a raw deal to call this improper. It's perfectly fine. There's nothing wrong with 3/2. It's not a wrong number. It just means that we have another way that we could write that and communicate the same information and stay in fractions. So the way we would do that is that we would make that a mixed number. So 3/2 is the same as 1 1/2. Okay, and this is a mixed number. So you'll run across all three of these. They're all three correct, but they behave differently depending on what we're using them for. The star players, when you're doing calculations, are the first two. Mixed numbers are problematic and a little bit dangerous. And I'll explain that in a little while. So typically when I do some of the problems that I'll talk about in this class, I would stay away from mixed numbers. What does that mean? That means that we have to change a mixed number. Let's make it a little more exciting. Let's say it is 2 3/4. We have to change the mixed number sometimes to, we have to change it to an improper. And to do that, we have to take the denominator times the whole number, and we have to add the numerator. I have that in the notes also, but we would take 2 times the 4, give us 8, right? And we would add the 3, so we would have 11, and we would maintain the same denominator, so we'd have 11/4. Okay, so that's changing the mixed number to an improper fraction. Then to go the other direction, we just have to ask ourselves, how many times does 4 go into 11? How many times does 4 go into 11? And we would say, well, I think I could put 4 into 11 twice. Twice, because 2 times 4 is 8, and 3 times 4 is 12, and that's too many, because I don't have 12, I only have 11. So 4 will go into 11 twice, so that is the 2, right? There are 2 versions of 4 in there. So that means my whole number is 2. That's what we know it is, right? And then we have to figure out how much do we have left over. So 8 out of 11 leaves 3, because 2 times 4 would be the 8. I already took that out in the whole number. 8, 9, 10, 11 means that the top is 3 because that's what I have left over, and the denominator stays the same. So that's how we go the other direction. Okay. Give me 1 second. I have to move something. Okay. All right. So onward. Hopefully this is all making some sense. Don't forget the Zooms. You can ask any questions you want live in the Zooms, and I will be working some of the problems that I talk about in a little while in those Zooms. So I encourage you to show up for those if it helps you. Okay, so let's talk about what we do with these fractions then. So what we're trying to accomplish is to be able to calculate some things, right? So that we can deal with the the fractions and calculate anything we want. So the first one I'm going to talk about is addition. So we're going to talk about addition and subtraction first. So addition of fractions requires a common denominator. So, for example, if we had 2/3 plus, let's see, I'm thinking of a number. Let's go with a 1/12. Let's say 7/12. So if we have something like this and it's an addition problem, what that means is we need that common denominator. So we were all told, really, when we were first taught this, that the best way to go is the least common denominator, which is certainly helpful. Least common denominator is a good way to go. But I'm also going to tell you that it doesn't matter. So if you see it already, the least common denominator would be 12. So you might already see that, and I'm going to demonstrate it. So if we need both of these numbers to be the same, we could multiply 2/3 times something to get the bottom to be 12. What is that? That's right, it's 4. So I could multiply the top and the bottom by 4, and that would get me to, I'm going to say equals, that would get me to 8/12 plus 7/12. Follow me? So I didn't have to change the 7/12. And then we would just add the top numbers, 8 plus 7, so 15, and divide that by the same, or I'm sorry, and the bottom would be the same denominator. So we don't add denominators, they stay the same. They stay with that common. But if I go back to the beginning here and I didn't actually see that, I could always, it will always work, is I could multiply the two numbers together and I could use my common denominator, it would be 36. So that's more work in the reduction phase, but if you don't see a common denominator because the two numbers are a little bit, it's not obvious, this one's a little bit more obvious, then you could always multiply the two together and that would be a common denominator. So back here to the end, what I need to do still is reduce this fraction. So we talked about equality of fractions. So equality of fractions also goes the other way where I could make them smaller. So if you think about it, what could I divide the top and the bottom by? That's right, I could divide this by 3, right? And I could divide this by 3. That would be a flood warning on my phone. So if I divide both of those by 3, what do we get? That's right, you know it. It would be 5 on the top and it would be 4 on the bottom. So we have 5/4. So that is an improper fraction in simplest terms, but then typically, unless we were in the middle of using this for a calculation, we would change this to a mixed number. So 4 would go into 5 one time, so I have one whole number, one whole 4, and then I have 1/4 left over. So that's the mixed number version. So this would be the answer in mixed number. This would be the answer in improper fraction. Okay, so The next thing to talk about then is subtraction. So we're actually going to use, well, let's use a different set, and I'll show you what I was talking about multiplication. So let's say I have, well, let's stick with 2/3 again, and we had okay, so we have 2/3 plus 5/8. So in this case, we need a common denominator, and we couldn't multiply 2/3 times anything to make it an 8. It won't work, right? Like 3 times 2 is 6, 3 times 3 is 9, so we can't get to 8. So that means we have to change both of them. And actually, because we're going to talk about subtraction, let's do it this way. We're going to subtract. So we need to change both of these to a same number, and we're going to have to change each. So one thing I can always think about is, what if I multiplied them together? So 3 times 8 would be 24. I could use 24 as a common denominator. So if I do that, I would multiply this. Let me get something that looks very different in color. So I would multiply this by 8 and 8, and I would multiply this by 3 and 3. So what we would end up with on the other side would be 16 24ths minus 15 24ths. And then we would just subtract the numbers on the top, and the bottom does not change in subtraction, so we would have 1/24, and that would be our answer because it would be in simplest form. Hopefully that makes some sense. All right, so subtraction and addition work pretty much the same way. It's just whether or not you have a plus or a minus in between. They require the common denominator. Okay, so the next piece, get a new piece of paper here. The next piece is multiplication and division. So just like addition and subtraction have a lot in common, so do multiplication and division. So we want to multiply fractions. So multiplication is the easiest one. So I'm going to stick with our first example. We had 2/3. If we want to multiply that by 7/12, all we do is multiply across the top and multiply across the bottom. So we would end up with 14 on the top and 36 on the bottom. Then we would need to simplify because that is not simplified. So we would say, okay, what can we divide the top and the bottom by? And I think the best we're going to do is 2, because the top then becomes 7, which is a prime number, which means it doesn't divide into anything else. And then the bottom one here would divide into 18. 36 divided by 2 should be 18, so we're at 7/18, which is a proper fraction, which means that this is end of the road for that. Let's look at division. So multiplication is easy. You just multiply across the top, multiply across the bottom, simplify your fraction. Division is nearly as easy. So division of fractions means that let's say we start out with the same ones. Let's use our second example. I want to divide by 5/8. Okay, so I have 2/3 divided by 5/8. So division of fractions is equivalent to 2/3 times its inverse. So these are equal. So if I take 2/3 and divide it by 5/8, it's the same thing as 2/3 times 8/5. Well, that's a beautiful thing because now I can multiply across the top and multiply across the bottom, and voila, I have my answer. So I have 16 on the top, I have 15 on the bottom. That is an improper fraction, right? So we could easily take 1/15 out of there, which means we have 1/15 left. Okay, hopefully that makes sense. So these would be our final answers: improper and mixed number. Okay, for division. So division of fractions and multiplication of fractions usually are the easy ones because we don't have to worry about the common denominator. Okay, so let's move on. Let's move on to working with decimals. So I'm going to talk next about decimal numbers. We just covered fractions. We're going to talk about when we change a fraction to a decimal number and what that means to us. Decimal numbers are incredibly important and common in the career paths that are represented in this class. So we deal with fractions enough that they're important, but decimal numbers are the majority of what we'll see on things like blueprints and drawings and that sort of thing. Construction probably likely sees more fraction sorts of dimensions than we do in, say, manufacturing, but we all run across both of them. So let's talk about decimal numbers for a little bit. So decimal numbers are actually fractions and they are interchangeable. So to get from a fraction to a decimal, we simply divide the top by the bottom. So we see I have 3/4 is equal to 0.75, and the way we can get that is to simply divide 3 by 4. 3 divided by 4. So we also see that it is a relationship between the top and the bottom. So the one that's next to that, the 75/100, also represents something that we'll talk about next week, which is percentage, or something that's always base 100. So they are equivalent most of the time. So we'll look at a couple examples there. And we'll also talk about how to go back and forth between fractions and decimals. And then I'm not going to go through this in great detail because, quite honestly, most of the time we're going to use a calculator, and I'm fine with that. But I do have the instructions in the handout that I have on the screen that has to do with adding and subtracting and multiplying and dividing without a calculator. You certainly can do this. Sometimes students prefer to do it all by hand, but you don't have to. And then I will talk about this section down here when I talk about the problem-solving process in the second screencast. But let me go back to my document camera here, and we will take a look at some examples. If I can get this to move off. There we go. Lots of stuff on my desktop right now. Okay. So let's go back to our document camera here, and we will see what we can do with decimals. So here's a couple of things to consider. And I'll talk about this kind of in more great detail in the Zooms, but decimals are incredibly useful, but they have some drawbacks compared to fractions. So, for example, if I say 1/2, how do I reflect that as a decimal number? You would say that's 0.5. And I would say, right on, that's 0.5. If I said what is 1/4 as a decimal, you would say, Heather, that's 0.25. Not terribly difficult, right? So let's look at the thirds. If I say, what is 1/3 as a decimal, you would say, Heather, that's 0.3. And somebody else would say, no, it's 0.33. And then somebody else would say, it's 0.333. And you get the idea, because what it is 0.3 repeating. So herein lies the difficulty between a decimal number and a fraction, because sometimes we have repeating numbers when we interchange one versus the other. So let's just talk for a minute on this side of how we would change these back to a fraction. Well, this one here is 0.5 is in the 10th position. That is a 10th. The 0.25 has a 2 in the 10th position and a 5 in the 100th position. That's important to note because how we change them back to fractions is we put them over the decimal that they are in. So that is in the tens. So this would be 5 over 10. The 0.25 is in the hundredths. So this one will be 25 over 100. And then we would simplify by dividing the top and the bottom. I'm going to divide by 5 here. I'm going to divide by 25 here. And that's going to get me back to 1/2 and 1/4. Okay, all fine and good, right? Let's go to the third. Let's say for just simplistic sake that we wrote down this as 0.333. So we'd said 1 divided by 3 is 0.333, and we're going to cut it off there. The little line over the top means repeating. So we know that 3 repeats. Now we want to change this back to a fraction. So now I say, okay, that's 333 divided by, what position is the last 3 in? Well, it's in the 1000th. So I'm over 1,000. And now I'm going to simplify. So I'm going to divide the top and the bottom by something to get back to 1/3. So if I divide this by, if I divide the top and the bottom by 333, this will come out as 1, but this will not come out as 3. You will get a weird decimal number is what you're going to get there. And that's because we cannot reverse this back to 1/3. Because the only thing that's a decimal version of a number that is exactly 1/3 would be 0.333 forever. So we can't ever put it over something and get it back to go back to where we started because we're rounding. So this is rounding error, which we will talk a lot about in this class because it has everything to do with how we use decimals in manufacturing and construction and automotive and fire science and pretty much every career you can think of. If we use decimals, then we have to be careful and very aware of what rounding errors we are incurring when we change fraction numbers to decimals. So it causes us a bit of a struggle. It's not a big deal as long as we know what we're doing, but I will talk a lot in here about rounding and how you don't round till the end of a problem and why you don't round till the end of a problem. So this is really kind of the big overreaching point that we have to get to with the decimal numbers. They're not difficult to deal with as long as we know how to go backwards and forwards. So we know how to get from one fraction to a decimal number and back again. But we'll deal with them a lot where really the question is kind of this, like what kind of rounding errors are okay and how many decimals do we actually need? And when do we round and what do we do with that? So typically in this class, if we have numbers that are, let's say we had a problem and we had some numbers that were something like this. We had 1.25, we had 1.305, we had 2.4, and we have 0.5. So if I looked at these numbers and I said, let's say we were adding them, something simple. And I said, how many decimals should the answer have? And the answer really is, well, which one's the limiting factor? You know, what here is more accurate and what's less accurate? Well, if we look at this number here, we have a higher level of precision because we have 3 decimals, right? We're going out to the thousands with this number. So we can measure this with something like calipers, right? If we look at this one down here, well, if that's a 1/2 inch, say, or a 1/2 foot or whatever, I could measure that with a tape measure, right? Because I'm saying that nothing after that 5 matters. So there's a big difference in the level of confidence that we have in the accuracy of the numbers and the measurements. So if we mix accuracies like this, then really the two that are the limiting factors here are these last two, because they only have 1 decimal. It's this one and this one. So those are limiting the ability for this 1.305 to have any impact whatsoever, that 0.5. Because these aren't accurate enough, we can measure them with a tape measure, to really be in the same world as this one. And for an example, if we saw something like this on a print, this number, if these were all on the same blueprint, this number here would be a critical measurement for something like inspection. And we do expect that that dimension would hold its accuracy at 1.305, and that would be the requirement, where this 2.4 is not critical and could even be like a reference dimension, where we don't actually use that for inspection. So those are just some examples of where you would see this kind of discrepancy. Prints usually would be like a 2 decimal and a 3 decimal mixed on the same print, in manufacturing anyway. So how many decimals should the answer actually have? In this class, what we're going to use is, if we find what the least accurate components are to the question, then we can add 1 more decimal beyond that. So I would look for the answer for this problem to be in 2 decimals. Now, for the class, you don't really need to worry about that too much, because of the way you do your work for your assessment, your weekly assessments. I tell you how many decimals that you want to input. But what I will talk a lot about in real world applications, how many decimals would actually be valid. So we would look for a 2 decimal answer here. Okay, hopefully that makes some sense. That is it for this one. Thank you for tuning in for fraction decimals. And go ahead and watch the problem solving process screencast, and I'll hopefully see you in the Zooms.